Okay, for chapter 10, one of the topics we are going to cover is conic sections. So I'm adding in section 10.0, which is an intro to conics, so we can get acquainted with the shapes and the standard forms of each of these shapes. Okay, now the first conic section is a circle, which you are already familiar with. Standard form x minus h squared plus y minus k squared equals r squared, where the center is hk and the radius is r. So if I look at example 1, this is already in standard form. The center of this is 5, -2. The radius is going to be, the radius squared is equal to 11, which means the radius is equal to the square root of 11. And I'm going to go ahead and sketch my graph. Okay, the center is at 5, -2. 1, 2, 3, 4, 5, -2. Okay, I don't have graph paper. If you don't, that's okay too. The square root of 11, I'm going to approximate, but I'm still going to try to get the 4 good points on my circle. The square root of 11 is 3 point something because it's higher than square root 9 and lower than square root 16. So from the center, I'm going to go 3.7, 3 point something to the right, a little bit more, 3 point something up, 1, 2, 3 point something, 1, 2, 3 point something, 2, 3 point something. Okay, and then I'll get a good approximation for my circle. Remember to make your circle round. Oh, mine looks a little bit oblong there. Okay, that's the general equation for a circle. Okay, next we're going to look at an ellipse. Ellipse is what you might call an oval shape. It still has the format x minus h squared plus y minus k squared. It still has a center at hk, because it might be longer in the x or y direction, it has an x radius and a y radius. So below the x minus h squared, we have rx squared. Before the y minus k squared, we have ry squared, where rx is the x radius, ry is the y radius. It should always equal to 1 when it's in standard form. So for example, 2a, it's x squared over 9 plus y squared over 25. So in this case, the center will be 0, 0. Below the x term is the x radius squared, which means the x radius should be the square root of 9, which is 3. The y radius is squared underneath the y term, under here. So the y radius is going to be square root of 25, which is 5. I'm going to go ahead and sketch the graph, and I'm going to identify a few key features on this thing. Okay, center is 0, 0. Let's see, the x radius is 3. So in the x direction on either side of the center, I go 3. In the y direction, the y radius is 5. And then I'm going to sketch my ellipse. It should be curved. In this case, it's kind of a tall ellipse, which is fine. Okay, now a couple words on this thing. The first thing is a major axis, or the length of the major axis. Think of an axis kind of as a diameter. Major means the bigger, or the bigger one. So this is really asking, what's the longer diameter of this ellipse? So in this case, this is taller than it is wide. So in the tall direction, the diameter would be 5 plus 5. So the major axis length is 10. It's the entire distance across. Okay, the minor axis length will be the diameter in the short direction, which in this case is the x direction. Since the x radius was 3, 3 plus 3 gives me a minor axis length of 6. Okay, next word is vertices. Okay, the vertices are the endpoints of the major axis. Okay, so I'm going to think this is going to have to do with the major. Okay, in this case, the major axis is in the vertical direction. So this is a vertice, and this is also a vertice. So up here, this is 0, 5, this is 0, negative 5. It's the endpoints of the major axis. The co-vertices are going to be the endpoints of the minor axis. So here and here, this is negative 3, 0, this is positive 3, 0. Okay, and then any new vocabulary we'll do in the next class. Okay, let's go ahead and look at one that's not centered at 0, 0. Now that we know the shape, this is still an ellipse. It is in standard form. I see that this center is going to be 1, 4. The x radius squared is under here. The y radius squared is under here, and this has to equal to 1. Okay, let me identify the center. Center is 1, 4. The x radius would be the square root of 16, which is 4. The y radius is the square root of 5, which is the square root of 5. Okay, and then I'm going to go ahead and get a good graph. If I have graph paper, I will, of course, have a much nicer graph. Okay, center is 1, 4. X radius is 4. I'm just trying to space out my graph, and I'm going to 5. Okay, so 1, 4. 1, 1, 2, 3, 4 is up here. Okay, in the x direction, the radius is 4. So 1, 2, 3, 4. 1, 2, 3, 4. In the y direction, the radius is the square root of 5, which is 2 point something because it is bigger than the square root of 4. So let me look at this. 1, 2 point something. 1, 2 point something. Okay, and then that's going to be my ellipse. In this case, it's a little bit wider. Okay, the major axis length, remember the major axis is always going to be in the longer direction. Since the x radius is bigger than the y radius, the major axis will be in the x directions. Since the x radius is 4, that major axis length will be 4 plus 4, which will be 8. Okay, the minor axis length will be in the shorter direction, which is the y direction. The y radius is root 5, so this is square root 5 plus square root 5, which would give me 2 square root 5. Okay, the vertices are the endpoints of the major axis, so this point and this point. If you have a nice graph, you can just read it from your graph. I don't have the nicest graph, so I'm going to have to kind of calculate it. Okay, what was the center? The center was 1, 4. So the vertices are going to be at something 4. Something 4. And yes, if your graph is nice, just read it. Okay, the center was 1. X is 1. I went to the right 4, so 1 plus 4 is 5. And then from the center, x is 1, and the x radius was 4, so 1 minus 4 is negative 3. And if you have a good graph, this would look like 5, 4. This would look like negative 3, 4. Okay, for the co-vertices, it's the endpoints of the minor axis, so this one and this one. The x-coordinate's 1. Let's see, the center is at 1, 4, so the y here is 4. In the y direction, I went up root 5. Okay, and then for the other one, I started from the center and I went down square root 5. So those are going to be the exact coordinates of my co-vertices. Okay, the last shape we're going to look at today is called a hyperbola. It looks very similar to the ellipse formula. You see it still has the x minus h squared. Below it is the x radius squared, y minus k squared. Below it's the y radius squared. The difference is on an ellipse, there was always a positive here. If there is a minus here, it's going to be a hyperbola. Okay, it could switch. In this case, the y term is positive and the x term is negative. I'm going to show you what this looks like. The center will still be hk. and the x and y radius don't change either, but okay, let me look at this first standard form. If this was my center HK, in this case, because the x term is the positive term, this is going to open in the x direction. So the shape of the graph is actually going to be something like this, although we're going to make it look better than this in a second. Okay, it opens in the x direction because it has a positive x term. Okay, the vertices are this point and this point. Okay, because this is opening in the x direction, from the center, it's going to the right, Rx, and it's going to the left, Rx. So to find the vertices, in this case, it would be H plus or minus Rx, comma K. And your book sometimes uses A and B, which I'll show you in another section. Okay, for this second graph, which is very similar, except this time the y term is positive and the x term is negative, it's going to make it open in the y direction because the y term is positive. So it might look something like this. Okay, in this case, the vertices are here and here because it opened in the y direction. So if I want the vertices, the h stays the same, but in the y direction, the center was at k, and then I'm going to go up ry, and I'm going to go down ry. And of course, you can just get this from the graph as well. Okay, I'm going to go ahead and draw a hyperbola. We start out very similarly to an ellipse, and then we switch it up a little because it has different features in order to make this work. Okay, so for example, 3/8 x squared over 9 minus y squared over 25 equals 1. Okay, first thing, because there's a minus here, this is a hyperbola. It does equal 1. It is in standard form. Now I want to see which term is positive. Because the x squared over 9 is positive, this will open in the x direction. And I don't need to write anything. I just need to remember that for when I am graphing. Okay, the center on this thing is 0, 0. Okay, now I'm going to start it out like I'm graphing a ellipse, but I'm not going to draw an ellipse because it won't be an ellipse. So let's see, center 0, 0, x direction 3. Rx is 3, Ry is 5. 2, 3. Okay, Rx is 3. I'm going to mark that off. 1, 2, 3. Ry is 5. I'm going to mark that off. I am not going to draw an ellipse because this is not an ellipse. Okay, so there's a couple methods for drawing this. Your book and a lot of other places use what kind of like a box to guide it. Okay, so I'm going to imagine this is the midpoint of each of the sides of a rectangle. I'm going to draw a little dashed line for a rectangle. This rectangle is not part of the graph, but it does help guide my graph because there are asymptotes on this beautiful graph. Okay, now I'm going to draw the asymptotes. The asymptotes are important to the graph and they have to be included while the box does not. Okay, the asymptotes go through the corners of this rectangle I just drew. They are dashed because they're not actually part of it, and they do go through the center. So this is an asymptote. Do make it longer than the box. It's important because your graph will approach the asymptotes, but it won't pass the asymptotes. And eventually we'll find the equations of these asymptotes. Okay, now I'm ready to draw my parabola. Not my parabola, my hyperbola. Okay, this opens in the x direction. The vertices are going to be here and here, where I marked it off on my box because it's opening in the x direction. This should be curved and it should approach the asymptotes. So curving it this way towards the asymptotes, it has to approach the asymptotes. That's the right side. On the left side, same. Okay, that's my graph. This is my vertices. This is 3, 0. This is negative 3, 0. Let's try one more hyperbola because this one has a little extra work to it. Okay, let's try one that's not centered at 0, 0. Okay, so in this case, be careful with this, but the center is 3, negative 1, because this is x minus 3, this is y plus 1. It looks a little discombobulated, and that's because the y term is positive, but the x term is negative. because the y term is positive, this is going to open in the y direction. And again, you don't need to show any work to say that, just keep that in mind so that when we graph it, we get a good graph. Okay, so the center is 3, -1. Let me get a sketch going. 1, 2, 3, -1. Okay, so about here, my x radius is 2 because that's under the x term. X radius 2, 2. My y radius is 5 because of the square root of 25. 2, 3, 4, 5. And if you have graph paper, your graph will look significantly better than this. Okay, now pause because this is not an ellipse. This is a hyperbola. So I'm going to go ahead and draw a rectangle so that each of those points is the midpoint of a side. And this is to guide my asymptotes. Okay, the box is not necessary. When you get more comfortable, you might leave that up. But the asymptotes are required. So through the corners of the box and the center of the hyperbola, I'm drawing an asymptote. It should be dashed because it's not part of the graph, but it does guide the graph, so it needs to be, it is important to my graph. Okay, now this opens in the y direction because the y term was positive, so the vertex for each half of my hyperbola is at the top of the box in the y direction. So up here I have my vertex, so it's going to open towards the asymptotes. It should be approaching them. And then down here, it also approaches the asymptotes. The vertices on this are kind of like the vertices of each half of the parabola, hyperbola. So this thing right here and this thing right here, if you can read it off your graph, that's great. My graph is not the best, but the center is 3, -1. The y radius is 5, so from 3, -1, I went up 5. -1 plus 5 took me to 4. And then from 3, -1, I went down 5. So -1 down 5 took me to 3, -6. Okay, and then we will go more in depth into each of these different conics in a future section.